Our final surprise speaker, if you've only been going by the app instead of the paper copy of the agenda, is currently the technical director at Eckersley O'Callahan. He has almost a 30-year experience, a long history of engineering with glass substrates, and interested in technology and change. Please welcome Graham Coult.
Great. Well, thanks very much for sticking around. I certainly won't go beyond happy hour, so that's a safe stop point. So what I want to talk about today is something I've been working on with the University of Oxford and now Metamaterials more recently. And it's really to do, it came out of a discussion about circularity. And with these building models and tagging information on building materials and products in the building, the sort of the value of them is really being realized in 20 years. And because of work we've been doing with phase change coatings with the University of Oxford, my idea was to sort of change what we're doing with them slightly differently. And so it's creating some value for that tagging right now and bringing that straight into the fabrication process. So we're all aware of the kitemarks on the left, sort of digital static marks in the middle, and RFID tags. And they've been proven and tried. But as we move into sort of this new age of Internet and Things, I thought we might have a slightly smarter answer. So it's really using technology we first looked at for smart window glazing. So it's a phase change coating. And in difference from the electrochromic and other materials, it's a bistable element. So we switch it on, and it changes, and we apply another little pulse of energy, and it moves to the non-amorphous phase. And the example we did here, and Nathan was the postdoc working on it, was depositing a material on a panel, and depending on the performance requirements, it could be switched. And in this case, it was reflecting near-infrared. What was great about this is that you could tune the materials and tune the deposits and what we call the stacks on each on the design. And we got quite close, or I say we, they, got very close in terms of getting good neutrality in the color, and also a very, almost minimal difference between the visual light, whether it's turned on and turned off. So it avoided any change in how the user being in the building. And these are some results from the testing. And what we found is, from this is that it wasn't particularly performing better than a static coating with improved insulation. But really, and that was the finish of the postdoc, but that it's really about laying up the materials to do a particular job. So it's not necessarily the end, but certainly the end of the postdoc. So this is sort of the spectral graph of how it changed when we put the energy into the material. So what we're looking at with the phase change material is, what was particularly useful was this bistable switching. So it's not a constant power on or constant power off. It's the pulse of energy that switches it. And we looked to go, okay, well, why don't we use this for putting the information on the unit? Because we can deposit that information within, maybe it's a QR code, but it doesn't really matter. It's a digital format. So we write to it using a laser, a typical laser. But we can be we're completely free to write that information how we want. It could be digital, as in zeros and ones. It could be pictures. It could be kite marks. But where we found this was interesting is how we might be able to use it in the quality control process, because as it's running through the float plant, or it's not the float plant, the processing line, we can mark on information when it's been checked and so forth. And so it doesn't require going to the Internet of Things to do that. It's directly reading the information off the label. Actually, that's in the wrong place, so I'll skip past. So these were some samples we're using. So you can see on the left that there's some information written over in the samples, but it hasn't come out quite clear. But what I'll do is, this is a sample we had in our, well, we still have in our office. And this small circle is one of just a sample stack of coatings. It doesn't really matter what it is, but it still has the ability to phase change. So they just wrote in the label, or in the area, the phase change coating. But what that's useful in a certain sense. But what was really interesting, and so we could print onto labels that coating, and you could stick it on the glass, and that's great, and that's a really neat thing to do. But another change they were looking at was how to use it as an ink or a dye. So what they're actually doing is they do some lithography on a small sample. They sputter coat it, and they wash off the coating into these little flakes, and then it's held in suspension, and then it can be printed with a glorified inkjet printer. So nothing. I mean, what's really about this is none of the technology is particularly new. It's the development of the stack which makes it particularly interesting. So it comes into this, the dry powder is put in suspension, and then you just, inkjet print it on the object. I've done all that. And so the fidelity of the images is amazing. So you can see some of these. So that's come out as 10 millimeters, but that's actually 10 nanometers. So it's incredibly small. And the sort of exploded diagram on the left really gives an idea of what the stack is. But the way it works is really, as light's coming into the stack, it gets reflected back out and interferes with itself. So depending on the height and the materials using that stack, the color can change. And throughout the testing and the sampling, that they found that the gold to dark purple is on the left is probably one of the most contrasting states they have. I mean, we can also tune it to infrared, etc. And there's another example of the pale gold to bright. So here they are, that the actual laser is writing onto the material. And they're doing a tree, which is nice. And in the same way, I mean, now you can appreciate what the coating is. And because it's a digital, that you can encrypt information in there and so forth, or you have the link back to the Internet of Things if you wanted. But because also we can change how it filters light, we could also hide it to visible wavelengths. And so it's really very flexible in its approach. And so lastly, this was, again, this is a writing to the stack, but this is rewriting it. And what's great about this, and I was talking about security, and so we can choose the material so it's a write once. So for example, if we're looking at a stamp or an approval stamp, then it can be written and a write once, in the same way you have used to have CDs as write once. But also we can have it read and rewrite, and so you can delete it and then start something else. So it has an application for security, an application for information, and they're looking at applications for different aspects. But I think where it can help us in the glass world is providing functionality that we can use to mark glass, or it could be any material really, as we can apply this to sort of PET and other films and use it as a sticker. but it enables us to quickly write information to it. It can be secure, it could be publicly accessible, and therefore, from a maintenance perspective, you can use that throughout the maintenance life of the project, and then when it's coming to the end of the life, the public area would reveal what's in the glass, what coatings there are, what the thickness is, perhaps what the factory came from. So getting that back on the market as a resale value, whether it's being reused elsewhere or whether it's being sold for cullets, all that information is embodied on that small sample. So whether it's tiny little, less than 1 millimetre in size, that information can still be kept there. It's a standard processing, magnetron sputtering, but there's sort of the real cleverness in it, and that's nothing to do with me. It is really how that stack is built up and that recipe, if you like. And that's it. I told you I'd be quick.